Hello, this is Carlos Reyes, and in this short video, I'm going to walk you through the calculation of a Z level and also the link between the Z level and the probability of defects. So these lessons will teach you more about how to estimate how capable your process is to meet certain specification or certain requirements. So imagine that we have a delivery time of goods and services or delivery time of letters or whatever item you need to deliver. This is just a hypothetical example. So that means that is your CTQ for this particular process, your critical to quality. And imagine that you collect a sample out of that process and you want to know, you want to estimate a baseline and you want to know how capable your process is to meet certain customer requirements. So for this example, we're going to assume that these numbers follow a normal distribution. So therefore, we can use the mean and the standard deviation to characterize this distribution. So we use Excel to calculate the mean, which is 16.6, and we also calculate the standard deviation, which in this case is 5. So assume that we're representing this in number of days. So on average, it takes us 16.6 days to deliver this, let's call the report. And we have a standard deviation of 5 days on this particular process. Now, also, if we want to estimate the how capable your process is, the question is capable against what? Well, we're going to calculate how capable your process is against the limits that maybe the customer has established, and maybe we have an SLA, like service level agreement, that says that for this report, we don't want the process to exceed 25 days. But also, we don't want the process to be delivered before 10 days. Now, I'm using this as probably the more complex scenario, because there are times that you may see that we only have one limit. So, for example, so probably the customer says, I don't care if you deliver the report as soon as possible, just don't go beyond 25 days. So then we will be dealing with just one limit to calculate our capacity of this process. But again, in this case, we have the customer saying, I want it between 25 to 10 days. Now, next, we're going to say, okay, but what is the Z level linked to those spec limit? And remember, the Z level represents how many standard deviations I'm able to fit from the mean to the upper spec limit, and how many standard deviation I'm able to fit from the mean to the lower spec limit. So that's the calculation that I'm making here. So in this case, the Z level of the upper spec limit will be the upper spec limit, in this case 25, minus the mean, which is 16.6, divided by the standard deviation, which is 5. So this is telling me that in this process, I'm able to fit 1.7 sigmas, standard deviations, from 16.6 to 25. And then I'm also calculating the same thing for the lower spec limit. So now I have the Z level. What do I do with that? Well, the Z level really doesn't tell me much until I estimate what is the probability of defect linked to this particular Z level. Now, let's understand that a little bit better. So this is a representation of the distribution, including the upper spec limit, which is 25, the lower spec limit, which is 10, and again, these are the Z levels that we estimated. But this is important. We're not interested on the area or the probability of having these reports deliver between 10 to 25. Instead, we want to understand what is the probability of defect. So therefore, I'm not interested on this area, but I'm more interested on this yellow area, which is the probability that the report will go beyond 25, or on the lower side, the probability that the report will be delivered before the 10-day, which is the lower spec limit. And this is going to be important later when we calculate this using the tables. So remember, we don't want the interior, we want the defect probability. Okay? So let's go back to here. So we have 1.7. So now what? We want to know what is that probability of defect of a process that has a sigma level or a z level of 1.7. To do that, I learned many years ago to use the z tables, which basically I have here. Now notice that this z tables will give me the opposite of what I want, right? This table is saying I'm going to give you the probabilities of from the left to the right, and if you compare to what I just explained, this is going to give me not the area that I want, but the area that I don't want. But still, I'm going to use that to calculate this white area, which is the one I'm interested. So again, the z level is 1.7. So this is the z, and it says 1.7, and then it's 1.70, right? So then the probability linked to that is 0.9554. So if I write that down, 0.9554. So that is the cumulative area of that particular sea level. To calculate this defect area, all I need to do is basically, I know that the complete area under the curve is 1. So I just go 1 minus that area, and that is giving me 0.0446. What I found with that is the probability of defect, which is this yellow area that I'm highlighting here. Now, to calculate the probability of the lower spec limit, I'm going to do something very similar. Now, don't worry about the fact that this is negative. This is just saying that this z level is on the left side of the curve, and this, because it's positive, is on the right side of the curve. But you shouldn't worry about the negative numbers. So this, in this case, I have minus 1.32. Just to be more, to make it easier for you, I found a table that estimate this area right here. So this is exactly the area that we want, correct? So in this case, we have a C level of minus 132. So let's look at this. Minus 132.